All right, so we are at page 3, mutually exclusive events, and we're going through probability unions. So just exactly what are mutually two events when they are mutually exclusive. Okay, what mutually exclusive means is that the two events cannot have something in common. Okay, so let's say I asked you, the probability of you getting an A in the class. You either get an A, whatever the percentage is, or don't get an A. Okay, that is mutually exclusive because you cannot have for the class, you cannot have an A and a B. Okay, so this is what we mean by mutually exclusive. You cannot have, basically, you cannot share two or more different outcomes. Okay, it's got to be just one basic outcome. Okay, you either get the A or not. Okay, we will go into what is not a mutually exclusive event. Okay, oops. But basically, it is when mutually exclusive when event A and event B have no outcomes in common. Again, you cannot get an A and a B in the class. You cannot be at the movies and at school at the same time. Okay, those are mutually exclusive. Okay, a lot of times it is used as is stating that the intersection and A and B is not happening. Okay, that's why it's saying it's equal to 0. All right, so let's take a look at this. You draw one card at random from a standard deck of playing cards. Standard deck of 52 playing cards. What is the probability that the card is either a heart or a face card? Okay. So got a Venn diagram here. Okay. Okay, so we're going to write in here the hearts. Okay. We're going to call this part event A. Okay, so in the hearts you have your ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have jack, queen, and a king. Okay, so here we have face cards. Okay, we have the king of spades, king of diamonds, king of clubs, queen of all those, and the jacks. Okay, inside here is where they share. So that's the intersection. Okay. Okay, this is B. event B, and this intersection is A and B, where it is a heart and a face card. So since we could actually have two events in common, or two outcomes in common, these are not mutually exclusive. So the probability that we use for the union of two events is A union B equals the probability of A plus the probability of B minus probability of A intersection B. Okay, so here the probability that A occurs, okay, that it's a heart, okay, we've got 13 out of 52. Okay, 13 out of 52. Probability B, okay, that it's a face card. Well, we've got how many face cards? 1, 2, 3, 4, 12. So 12 face cards over 52. Okay, we got 13 hearts, 12 face cards. So we've got probability A, 13 out of 52 plus 12 out of 52 minus our intersection. Okay, so our intersection here, we've got 3 out of 52. So minus 3 out of 52. So 12, that's 25 minus 3. That gives us 22 out of 52. Okay, so that's our probability, getting the face card. If we wanted to go into decimals, this would be 0.42, so about a 42%. Okay. Chance that your card's going to be either a heart or a face card. Okay, so let's take a look at this. Example 8. The Human Resource Department of a company has compiled data showing that the numbers of years of service for each one. The table shows the results. It's right here. Okay. What is the probability that an employee chosen at random has 4 or fewer years of service? So 4 or fewer is 157. Okay, so that's going to be our NE, so that's 157. Okay, and a sample space is all this right here. So when we add that up, that is 529. So the probability E in there is 0.297, so about a 30% chance that employee chosen has 4 fewer years of service. Okay, now it says what is the probability has 9 or fewer years of service. Okay. So part B. You can do this 2 ways. You can add both of these together. Okay. And that would give you 246. Okay, and of course there's 529 to choose from, so that leaves us with 0.465, which is about 47%. Another way you could have done it, I mean, you could have said the probability of A, which is 0 to 4, union B, and we would make that be probability A. And we could make this a probability of B. So that would be the probability of A plus the probability of B. Okay. There's nothing in common. Okay, so this is 0 to 4, 5 to 9. And basically, that would have been 157, 529 plus 89, 529. Okay, which is the same thing as this. Okay, either or is going to work out fine. All right, so we just got independent events, and that's it for that.